Hey everyone, we will solve this today's LeetCode problem. This is relative ranks. So you are given an integer array. This is an easy problem, right? So you are given an integer array, score of size n, where score I is the score of the ith athlete in a competition. All the scores are guaranteed to be unique. Okay. So we have given a score I array, and all the scores are unique, right? So here it is given that if the athletes are placed on their score, where first place athletes has the highest score and the second place athlete has the second highest score and so on. So the first place athlete's rank should assign a gold medal, then silver, then bronze, right? And for the fourth place to the nth place athlete, their rank should be in their placement number as X number is X, right? So uh, if we see an example, so we have given the scores and we need to assign that which athlete score is at which rank, right? So suppose if you see here, this 5 is at top position, so it should be assigned a gold medal, right? So this 4 is at second, so this assigned silver medal. This assigned third, so it is assigned bronze medal. This uh, second score is at fourth position, so we will mark it as 4 and 5 accordingly, right? So if you see here, what we are doing, what is the question asking, that we need to assign the positions of athletes on basis of their scores, right? And scores are unique, right? So scores are unique also, right? So if we see here, so what we can do here, so this is a very easy problem, so I will just I think many of you have already solved it, that we need to anyhow find the index, so we need to find the order of, we need to anyhow maintain the order of athletes index, athletes score index, right? And also want to know its rank, so that uh, we can mark it, we can assign this as a gold medal or 1 2 3 4, right? Right. So what need to do, so here we see this is the 0th index, it is at first, it is at second, it is at third, it is at fourth, right? So this is the index, and we need to find the rank, right? So if we store this score and index with it, so what does it mean? So if I make it as a pair, 8 2 9 3, right? And then simply short it. If I short it, so what does it become? 8 on the and we short it according to scores, so it will become 10 9 8 4 and 3, right? But its index value is changed because its orders is changed, so that's why I need to store this index with it, so that its order, so that I can store, get its previous index value after sorting, right? So now this 10th index is 0, 9 index is 3, right? 8 index is 2, 4 index is 4, and 3 index is 1, right? Now what we will do, we will iterate in this new vector of pair, and go to this position and mark this at gold, mark this as silver, mark this as bronze. And if I go to this fourth value, this is at fourth, so we will mark this fourth, it is at fifth, so mark it as fifth, and mark it as previous 1 2 4 3, right? So this is how we will solve this question, right? So let's implement this, right? Let's implement this. So I think you have understood that why we need to store this index with this code, because after sorting, its indices and order gets changed, and we want we don't want that. We want to just maintain the order and assign the ranks according to their scores, right? So we want to maintain that order, so that so for that I need to store the indices with it, right? So let's see how we can implement this. So here score.site, and now I need to maintain a pair, need to make a pair of this int and indices, and then I need to make a pair for it. So what I will do, I will start iterating in this score and push it with a pair, right? So this is how we make pair in C++, or you can use a make underscore pair also, right? So the first will be scored, because we want to sort it according to this, and second will be the indices. Now what we need to do, we need to sort it. So what we will sort it, we will sort in descending order. So for that we can use r begin, right, and r end, v dot r end. So this r end and r begin is in reverse order, right? You can also use a comparator operator, where we can you can use a make a comparator function and this, but I prefer to choose this if I want to if I want to sort in descending order, right? So now what we need to do, we need to make a string to return an answer, right? That will be of size n, right? Now we will iterate in this b, right, which is again n. Now for this n, I need to store this as answer. So for that, I need to make an index here. So the previous index, what was that? What that was vi dot second. The previous index was vi dot second. So I need to update this indices according to that, right? So the first should be gold medal, the second should be silver medal, and third should be bronze medal, right? So for that, I will assign that ranks. I will make this as a dynamic and assign this as gold medal and silver. So I will just copy this and paste this in, right? So I've just assigned the gold medal, silver medal, and bronze medal two ranks. So this is for 0, this is 1, this is 2. So what will I do? I will see that if my indices is less than equals to 2, so I will just assign answer int to the ranks int, right? Otherwise I will assign this sorry, this should be I, which is I less than 2. So this should be ranks I, because this 0, 1 and 2 should be ranks here, and this answer int should be 2 string of I plus 1, because after 2 there will be 3. So here index is 3 but rank should be 4, right? Here index is 3 but rank should be 4, that's why 2 string to I plus 1, right? And we will just return this answer here. So let's run this. Yeah, we have passed the sample case. Let's submit it. So we have successfully passed this test case. So if you see here, if you see here that in this, what is the time and the space complexity will be? So the time complexity is can is that I need to iterate in this O of n, then I am shorting it, that takes O of n log n, then I'm again iterating in O of n. So that will be O of n, then O of n log n, because I need to short it, and again O of n for again iteration. So overall it is O of n log n, right? And the space complexity is, so we are taking an extra vector to store this score and this index, so that's take O of n, right? Plus if you consider this string as an extra for returning this, so that will be again n O of n. So overall that will be O of n, right? So this will be so this will be the time and space complexity, right? So if you see, we can also solve this is an different approach. So this is the one of the approach we can solve using vector, right? So the second approach can be, although it's not needed because the time the space complexity will be same, you can use heap also here, right? So what we can do, you can just store this index, this the same like this index and the score in priority queue, and start start popping out from priority queue, and do this the same thing, this like this, start popping out from this priority queue, and start assigning this to answer, right, and return that, right. So that's the same approach. So what we can do, we can uh, do the same with priority queue. We can insert the pair consist of score and index, and then pop out the top element of priority queue. So this should be the max heap, right? This will be the max heap element of priority queue, and assign to the stored index value, stored index in answer, just we have done in vector pair, right? So for if you use maxif, then we don't need to short this again because it is already sorted. So that will again take n of log n, because for every element it's take log of n to short it in maxif. So it will take again o of n log n, and the space complexity will be again o of n due to insert and taking an extra space of priority given. So the approach is same, just using a different data structure, right, and the time and the space complexity will not be affected, right, as such. So uh, that will be the same approach here, right. So these are the two approaches which we can solve this easy problems, right. So hope you like it. You can implement this priority queue by your own, right. You should implement this maxip approach by your own for practice, right. So you should, for practice you should do this and see that whether you can implement it or not, right. I have told you the approach. So yeah, thank you. Bye bye.